I will now be going over the ThunderBox over and under voltage emergency stop tests. For this engineering requirement, we have to be able to detect the ThunderBox exiting its designed supply voltage window of 30 to 55 volts DC and report that on the emergency stop bus within 10 milliseconds. Currently, we have it set up running at 45 volts, and we will turn on another power supply to push the ThunderBox above 55 volts to trigger the overvoltage e-stop. We'll be measuring the timing on the oscilloscope, which we have a 10 millisecond window already set up. It's designed to trigger off of 55 volts. So if we get a rising edge of our e-stop in that window, we will pass the overvoltage condition. So go ahead, fire up that power supply, and we can see it's crossing the first cursor, and then in about 7 milliseconds, within that window of 10 milliseconds, it's reporting an overvoltage condition. So now we'll reset the supplies and do the undervoltage test for 30 volts. Now we'll do the undervoltage test. So we have the ThunderBox set up again, running at a little over 30 volts, and we'll turn off the power supply and drop below 30 volts, and we'll see it on the scope. Once again, we need to hit the 10 millisecond window. So I'll go ahead and shut off this power supply, and then here we have it. It's set to trigger at the 0 mark at 30 volts, and it's almost instantaneous here. So if we zoom in a little bit, that is less than 1 millisecond, so about 0.7 milliseconds. So that satisfies this engineering requirement for the over and under voltage emergency stop on the ThunderBox.